Hi, I'm Ramakers from University, and in this work we're introducing and presenting measurement patterns. This work is done together with my colleagues Leen, Kris, Luyten and Veuskens from University, as well as Jeeeun from Texas University and Houben from Eindhoven University of Technology. So let me first start with a short introduction on measurement problems during making processes. So it's quite well known that the large majority of errors during making processes can in the end be traced back to problems related to dimensions. Research also shows that human actually makes a lot of mistakes when handling dimensions. For example, when incorrectly reading a measurement from an instrument, or by incorrectly aligning an instrument with an object, or by transferring problems related to transferring a measurement from an instrument to a workpiece or digital system. And mistakes happen all the time when handling dimensions in various processes, also such as the one you see here on the current slide. But you would imagine that such problems barely occur given the current generations of technology that are available. However, 2 years ago, a similar problem occurred right next to our university campus, where contractors started with constructing a new bicycle tunnel, and they started with the foundation on both sides of the tunnel, and at some point a few weeks later they noticed that on the one end it's half a meter too low and on the other end it's half a meter too high, so they had to redo the entire thing. But dimensional mistakes do not only happen during the actual measurement activity, they can also be the result from factors during making processes that were not considered correctly. For example, not compensating for curve during laser cutting, or the shrinkage of ABS filament while 3D printing. In science and engineering, the field of metrology specifically focuses on measurement, but the main focus is actually on the technical aspects of measurement, such as defining and enforcing standards, highly accurate measurements, and defining uncertainties. This is quite logical, as this field and its focus originates from the Industrial Revolution, which required parts to be produced precisely according to different standards for those parts to fit together. However, we notice that the user aspects of measurements are actually a lot less considered. For example, how do users know which measurement instruments to use and how to use these instruments correctly, how to read from them, and how to precisely align them with the workpiece. These protocols are oftentimes quite invisible. Also, how should they know which characteristics to consider when establishing a dimension? Or how do they know all the implications when choosing a new dimension? So while little research in HCI actually exists, which specifically considers the user aspects of measurements, various systems have been built that embed new interactive modalities and processes that actually significantly impacts how users deal with dimensions or conduct measurements. For example, systems to automatically inject measurements in CAD environments, the use of gestures or body measures to express dimensions, or the use of existing objects and their sizes to model new objects, or the use of clever mechanisms to automatically compensate for curve in the laser cutting process. So these more user-oriented strategies greatly facilitate handling dimensions during making processes, but they're often much more hidden inside larger system contributions. So to reveal these more user-oriented strategies, we conducted an extensive literature study in which we reviewed 157 relevant articles and 36 commercially available systems and well-known practices related to digital fabrication, prototyping, craft making, and modeling. And we looked at these articles and existing systems from the perspective of measurement. So we identified strategies to facilitate measurements that are oftentimes deeply hidden inside these bigger system contributions. So we looked beyond the core contribution of these papers. And this resulted in 127 user-oriented strategies for dealing with measurements and dimensions in making processes. Multiple authors also went through this entire set and used an open coding process to characterize each of these strategies. And in the end, this resulted in 10 different measurement patterns. We define measurement patterns as reusable strategies for commonly occurring difficulties when dealing with dimensions throughout the making process. And this is similar to the use of patterns in software engineering and user interface design. So every measurement pattern includes a generic description of what the solution entails, the measurement problem it resolves, how it can be used, an example uses in existing systems, and related patterns that can often be used together. So in the following slides, I will give a few examples of how measurement patterns can practically be used when building a display shelf that fits, for example, a conical shaped pot as you see here on the slide. So when holding the plank against the wall, we encounter the first measurement-related challenge, as it turns out that the wall is slightly curved. Instead of trying to measure the curve of the wall, we use measurement pattern 10, shortcuts for making marks, which include strategies for making precise marks by translating a complex measurements challenge into a simpler equivalent operation. In this case, we use a washer and a pencil to transfer the curve of the wall onto the plank, as you see here on the slide. In a later stage, a jigsaw can then be used to precisely cut along the traced path. In a second stage, we need to cut the actual hole in the plank for fitting the conical shaped pot. And instead of trying to measure the dimensions of this pot, we use a different approach, starting with measurement pattern 3, which includes strategies to measure objects using 3D reconstruction techniques. For example, by taking multiple photos of the pot using a smartphone and using 3D reconstruction software. After the shape of the pot and the plank is digitized, pattern 5, designing with existing models, is used to create a hole in the plank without specifying the dimensions of this hole. And this can be done by simply positioning the pot and the plank with respect to each other and performing a Boolean subtract operation. To then make the actual hole in the plank, we create an export of the oval shaped hole and send it to the laser cutter, and then use this as a template for cutting the hole inside the plank with a plunge router. And this step actually leverages pattern 9, guiding manual tasks, as we create a constraint to guide the plunge router along an intricate path that would normally involve several complex measurement activities. After screwing 2 brackets to the plank, holes have to be drilled in the wall, precisely matching the distance between the 2 brackets. And here, pattern 10 can again be used, which include clever tricks using paper tape to transfer the holes onto the wall. The paper tape can then be applied to the wall and readjusted until it's perfectly leveled. And instead of using a spirit level, a leveling app on the phone can be used, which offer digital readouts of angles instead of looking at analog tick marks, which is oftentimes more error prone. This final step leverages pattern 1, digital readouts. But measurement patterns have more uses beyond their practical applicability for makers. Or measurement patterns also articulate new benefits of specific features and existing system contributions that are not yet commercially available. So this offers new reasons for valorizing specific features and turning them into new products. And very importantly, also for system engineers building new prototyping systems or workflows, measurement patterns can be used to consciously consider how and when end users will be exposed to dimensions, and how this can be facilitated using measurement patterns. Finally, for researchers in HEI and engineering, our work is a starting point for discussion and future work on the user aspects of measurements, which we think is largely underexplored. For every measurement pattern, our article therefore includes several paragraphs on open technical challenges related to these patterns. So if you want to know more or get an idea for your next research project, please go to our paper.